Hello students, welcome to my YouTube channel. See, today we will do here one question from set theory. This is a proof of two set. If A, B are two sets, then prove that A intersection B differentiate this is equals to phi. A union B intersection A this is equals to A, and A difference B this is equals to B complementation difference A complementation. We have to prove that. So we have to prove first one. Okay, for proving this, um, we are using here a subset concept. If this is subset of this phi and phi of subset of this, first one proof is there, that means phi is subset of all of the sets here. Okay, so we can write this. Now let uh, here we write it first, that means phi is a subset of all of sets. Phi is a subset of all of sets. So phi is a subset of A intersection B difference A. Now we have to prove that A intersection B difference A is a subset of phi. Okay, so let A and B are non-empty sets, and let A intersection B difference A not equals to phi. So let X be any element of A intersection B difference A. Okay, so here X belongs to A intersection B difference A. That imply X belongs to A and X belongs to B difference A. Intersection, for intersection we have to write here and. That imply X belongs to A and X belongs to B and X does not belongs to A for the definition of difference. That imply X belongs to A and X does not belongs to A and X belongs to B. We have to find that element which is belongs to A and does not belongs to A. There have no element which is belongs to a set and does not belongs to a and set, both are wholes here. Okay, so so here X belongs to A and X does not belongs to A is not true here. So A intersection B difference A is equals to phi. Proved here. Now question number 2. A union B intersection A this is equals to A. So we have to prove that A union B intersection A, it is a subset of A and A is a subset of A union B intersection A. Okay, if we prove this, then we can say that A union B intersection A this is equals to A. Okay, let X be any element of A union B intersection A. Okay, so X belongs to A union B intersection A. That imply X belongs to A union B and X belongs to A. That imply X belongs to A or X belongs to B and X belongs to A. Okay, that imply X belongs to A or B and X belongs to A. That imply X belongs to A. Okay, so A union B intersection A, it is a subset of A. This is equation number 1, and let Y be any element of A. Then y belongs to a implies that y belongs to a and y belongs to or y belongs to b. We can write it this here, um, this statement, okay. um, or y belongs to b and y belongs to a, okay. That imply y belongs to a union b and y belongs to a. That imply y belongs to a union b intersection a. This is equation number 2, okay. So from, sorry, not this is equation number 2. Here y belongs to a union b intersection a, that so that imply um, a is a subset of a union b intersection a. This is number 2, equation number 2. So 1 and from 1 and 2, this is not equation, this is from um, this is condition number 1 and 2, okay. So from 1 and 2, a union b intersection a, this is equals to a, okay. Now number 3, condition number 3 is a difference b, this is equals to b complementation difference a complementation, okay. So we have to prove that a difference b, it is a subset of b complementation difference a complementation, okay, and b complementation minus a complementation, it is subset of a difference b. For this, let x be any element of a difference b. So x belongs to a difference b, that imply x belongs to a and x does not belongs to b, that imply x does not belongs to a complementation and x belongs to b complementation, that imply x belongs to b complementation and x does not belongs to a complementation, okay. That imply x belongs to b complementation difference a complementation, okay. So x belongs to a difference b implies that x belongs to b complementation difference a complementation, therefore a difference b, it is a subset of b complementation difference a complementation, okay. uh, Now for reverse, let y be any element of b complementation minus a complementation. So y belongs to b complementation minus a complementation, that imply y belongs to b complementation and um, y belongs to b complementation and y does not belongs to a complementation na. That imply y does not belongs to b and y belongs to a, that imply y belongs to a and y does not belongs to b. We write it here um, in um, before b, okay. A is right here before b, that imply y belongs to a difference b. So y belongs to b complementation difference a complementation implies that y belongs to a difference b, that imply therefore b complementation minus a complementation, it is a subset of a difference b, okay. So from condition number 1 and 2, we can write it here, a difference b, this is equals to b complementation minus a complementation, proved here, okay. And if you have any questions, if you find problem in any question, then you can write it in comment section, I will solve it, okay. So it was the proof here, this is the video. Thanks for watching.